Hey everybody, today we're going to solve the find k closest elements problem on LeetCode. We're given a sorted array and two integers k and x. We need to find the k closest elements to x in the array. The result should be in sorted order. If there's a tie, the smaller element is preferred. So here's what it looks like. They're given 1, 2, 3, 4, 5. We need to find the four closest elements closest to 3, and that's 1, 2, 3, and 4. You see 5 is not included because 1 is smaller. And then 1, 2, 3, 4, 5 again, we need the four closest elements to -1. That's just 1, 2, 3, and 4. So we can solve this problem in two steps. The first thing we'll do is use binary search to find the index of the closest element. And then once we have the index of the closest element, we'll just expand two pointers around that index to include the k closest elements. So here's the original function. The first thing we do here is find closest using binary search. Let's take a look at what that looks like. So here's binary search. It's just typical binary search. We have a low pointer and a high pointer, which point at the ends of the array. And in order to find the closest, we keep track of a minimum difference. So the minimum difference between some element that we've seen and the target element. And then we keep a closest index. And the actual binary search code right here is the same as any typical binary search, except right here. So we calculate the mid like usual, midpoint, low plus high by 2. And then the candidate element is the element at the midpoint. And then here's the little extra addition to find the closest element. So if the absolute value of the candidate value minus the target value, which is this right here, candidate minus x, is less than the minimum difference that we've seen. What that means, so what this check means is this the closest element to the target that we've seen so far? And if it is, we just remember it. So we set the min diff to be that difference, and then we record closest to be the mid. So the closest element that we've seen so far is the mid index. And then the rest of the code looks just like binary search. If we found it, we just return mid, so we found the actual element. Else, if it's less, then low becomes mid plus 1. If it's greater than, high becomes mid minus 1. And at the end, if we haven't found it yet, we'll return the closest index. Now once we have that, we set our low pointer to be the closest index and the high pointer to be the closest index. And then all we do is we expand those low and high indices until we have a total of k elements. So while high minus low plus 1, so the number of elements in the range is less than k, and these two checks are just make sure we don't go out of bounds. Low is greater than 0, high is less than array length minus 1. If the absolute difference between the element at the low index minus the target is less than the difference between the element at the high index minus the target, then low minus minus. That's basically just bringing the lower element in. Else, we bring the higher element in. So all this is checking is which of the two elements, the one pointed at low or the one pointed at high, is closer to the target element. So at the end of this, all we have to do is check and see, have we actually found enough elements? And if not, that means that one of our pointers is either at the beginning or the end of the array. So we just expand out until we have enough elements. And then down here, we just set up our answer, and we add all the elements in our range, and then we return that answer. So that's it. Pretty simple problem. The idea is just know this implementation of binary search. A lot of people know how to do binary search to find the exact element. This is just a small tweak on that to find the closest element. Okay? And then once you have that, all we have to do is expand out and find the k closest elements.